Ready. Set. Secure.
Hi everyone, welcome back to another episode on Cloud Key Management. As the last option and episode in our series, we'll be taking a closer look at Hold Your Own Key. To better understand this use case and how some of the cloud providers are enabling this option for some of their native services, I'll be taking a deep dive into HashiCorp's Vault key hierarchy and look how we can protect Vault's keys by way of Hold Your Own Key. And at the end, I'll run through a demo showcasing 2 of the 3 features that Vault enables whenever you protect Vault's master key using an external key. So if you're ready, let's get started. In the last video, I talked about how Vault has a 2-tier key hierarchy consisting of the master key, which represents the top of the key hierarchy, and the storage key, which is used to encrypt our secrets and data. The security risk with these keys mostly lies with the storage key, as it was generated in software and is exposed in plain text and memory while Vault is unsealed, which exposes another security threat for an attacker to perform memory analysis on the system that Vault is running on top of, granting them access to our storage keys and secrets. We'll learn more about how we can use our own keys to mitigate this risk, but first let's take a closer look at the master key, as it represents the top of the key hierarchy, and it is the key that protects Vault's storage key. Vault master key has 3 purposes. At the time of starting Vault, Vault only knows of its backend storage, but doesn't know how to access or decrypt any of its data. Unsealing Vault is a process of obtaining the master key, which is then used to decrypt the storage key. We can also use the master key to generate a root token and use that root token to perform several administrative actions, and to rotate Vault's master key, which HashiCorp is calling rekey. It is also worth noting that Vault doesn't store the master key unless it's protected by another key. To better understand what I mean by this, let us take a look at all the different methods that we can use to protect Vault's master key. The first is by using the default Shamir secret sharing method, which splits the master key into equal parts, giving each participant its own unique part. The master key is then only reconstructed when the number of parts is applied based on the quorum policy configured at the time of initiating Vault. In theory, it is probably the best method to choose from when it comes to protecting Vault's master key, but in practice, many organizations forget to properly encrypt and securely store their unsealed keys, leaving them exposed in plain text, with 1 or 2 admins having access to all equal parts at best. To avoid some of the mishaps of not properly implementing the Shamir secret sharing method, let us look at 3 other methods we can choose from to protect Vault's master key while also simplifying our key lifecycle management process. The second method for protecting Vault's master key is by standing up a separate non-replica Vault cluster, enabling the transit secret engine, generate a key, and using that key to protect Vault's master key. This is a great way to learn how you can use your own key, but it's not something I would recommend in production when your Vault instances are storing secrets to some of your most sensitive data. The third option is by using one of the native key management services offered by many of the cloud providers. These include AWS KMS, Azure Key Vault, or Cloud KMS. By using any of these native cloud services, we can generate a key and use that key to protect Vault's master key. To learn more about the different custom master key types, check out our native KMS overview video where we break down the different key types for AWS KMS. The last option is the one that gives us the highest security assurance of our key, is the one we can hold our own key using a FIPS 140-2 validated key management or hardware security module appliance to generate a key and use that key to protect Vault's master key. By using any of the last 3 methods, we enable 3 other features of Vault when we protect Vault's master key using an external key. These include auto unsealed, seal wrapping, and entropy augmentation, which goes back to addressing the security risk with generating keys and software by using an external hardware true random generator when that level of entropy and randomness is desired. We'll explore the first 2 features in our demo, but first let's review what happens when we start Vault for the first time. At the time of starting Vault only knows of its backend storage based on the stanza defined in Vault's configuration file, but doesn't know how to access, encrypt, or decrypt any of its data. When we start Vault, it goes through the process of obtaining both the storage key and the master key, and if it finds the sealed stanza, it will encrypt and store a copy of the master key, pending waiting to initialize Vault for the first time or join an existing Vault cluster that has already been initialized before completely unsealing. For our demo, I initialized the first Vault node, generate a set of recovery keys, which will be used to generate a root token and to rotate the master key. At this point, Vault will unseal itself, marking itself as the leader as it is the first node in the cluster. I've also started and joined the second node to the cluster. In our demo, I'll begin by starting the third Vault node and join that node to our existing Vault cluster. At the end, I'll show how by enabling seal wrapping to our secrets engine, we're able to re-encrypt our secrets using the same key specified in the seal stanza, adding an extra layer of protection. And now that we got that out of the way, let's switch over to my desktop for a quick demo. Here we have several sessions connected to all three nodes. On the left, and starting from the top, we have a session connected to our first, second, and third vault nodes. And on the right of each vault node is a duplicate session with an active TCP dump that will display a string of packet header information whenever any one of our vault nodes attempts to communicate with our key stored inside our Remetric Data Security Manager appliance that we own and control. We can also see that when I type vault operator raf list peers, that this node is currently the leader of the cluster and that we have one other follower. Now, if I switch over to vault number 3 and do a sudo systemctl status vault, we can see that vault has not been started before. To start vault for the first time, let's type sudo systemctl start vault, and now to the right of our session, we can see vaults communicating with our HSM based on the seal stanza and attempting to encrypt its master key. Now, if I type sudo systemctl status vault, we can now see that vault is now active and running. But if we do a vault status, we can see that vault is still in a seal state. That's because vault is still waiting to be initialized for the first time or to join an existing cluster. Before I join node 3 to the cluster, let's double check that our node 1 is still the leader, which we can see that it is. Now let's switch back to vault node number 3 to join a cluster. I'll copy and paste the command, which reads vault operator raf join followed by the URL and listening port of the leader. In our case, the host name is 172.31.64.234, listening on port 8200. And as soon as we hit enter, vault displays an output that shows a successful join. You might also notice that node number 1 made a call to our HSM. I have a theory or an idea as to why, but to save time, let's keep going. Now, if I go back to node number 1 and list the peers of our cluster, we can see that we have 2 followers, which includes the third vault node we just joined. And if I do a vault status back on vault node number 3, we can see that vault is now in an unseal state. As a final way of showing how vault auto unseal works, let's restart vault node number 1 by typing sudo systemctl restart vault, and as soon as we hit enter, we can see an exchange between our HSM appliance and both vault node number 1 and number 2 by way of auto unsealing. And if I list the peers once again, we can now see that we are no longer the leader and the leader is now node number 2. Before we end our demo, let's write a secret inside a production namespace where I have a secret key value engine with the seal wrapping option enabled. And if I hit enter, we can see Vault making a call to our HSM appliance, indicating that our secret is now being re-encrypted using a key that we own, also known as hold your own key, instead of simply having our secrets encrypted with the source key that Vault generated at the time of starting Vault. Well guys, that completes this episode in our series on cloud key management. Hopefully throughout the series, you've been able to gain a better understanding of the different cloud key management options that are available to you when it comes to protecting your data at rest. My name is Victor, I want to thank you for watching, and I'll see you guys until next time.